Question number 35 says, if g prime squared equals g of x for all real x, and it gives you a couple initial conditions of g of 0 equals 0 and g of 4 equals 4, it wants you to find the value of g of 1. So basically we need to solve for g. Okay, and the way we do this is we can express g prime as a differential equation. So let's say y is equal to g. And that means then that y dy by dx is equal to g prime. And then we end up with this expression of dy by dx all squared, which is g prime squared, is equal to y. And we can separate and integrate this if we can get rid of that squared around the dy by dx. And we do this by square rooting. Okay, so when we square root this, we get square root y equals dy by dx. We can then separate and integrate this. So we get dy over root y is equal to dx. Integrate both sides. The antiderivative of this works out to be 2 root y. So negative power 1/2 becomes positive 1/2. We divide by the power 1/2, which is times by 2. And then for x, we just get x plus c. So we need to solve for c. We can do that at any point. So we'll do that here. So I'm going to plug in x is 0, y is 0. Or we can also plug in x is 4, y is 4. Either one will allow us to solve for c. So when I plug in 2 square root 0 equals 0 plus c, you can see that c is equal to 0. And if you plug in 4 and 4, you'd also get the same result. So at this point, my equation looks like this. 2 square root y equals x plus 0. I can solve for y. I end up with x over 2 squared. So we end up with x squared over 4. So my equation is equal to x squared over 4. So g of x is x squared over 4. And at this point, I can plug in the g value when x is 1. That gives me 1 over 4. So the answer is A.